anyway. Okay, in 7.1, we already apply law of sines. And in a case where we know two sides, two angles and one side. Two angles and one side. Now, law of sines is given by sine A over A equals to sine B over B equals to sine C over C. And I said last time, we can only apply law of sines if one pair of angle and opposite side is known. Okay, so either this is known or this is known or this is known. Then we can use law of sine. Now, in this section, we will apply law of sines into another case where we know two sides and one angle. If we know two sides and one angle. Now, this section can be confusing, especially of your lack of some geometry background. The first one, I believe the first one is something you already know, that the sum of interior angles of a triangle is 180 degrees. In other words, if I add this angle here, plus this angle here, plus the angle here, the total has to be 180 degrees. Now, consequently, if I add only two of them, let's say I add angle A and angle C, then the sum has to be strictly less than 180 degrees, right? Okay, if I add any two, of these three angles, the sum has to be strictly less than 180 degrees. Should be less than 180 degrees. Now, that's the first one. But I believe that's something you already know. The one that you may not know yet is the following fact. Suppose this is side A, and this is side B, this is side A, and this is side C. Now, another fact that we know is the larger the angle, the longer the opposite side. In other words, the largest angle of that triangle correspond to the longest side. And the smallest angle corresponds to the shortest side. Okay, now that's the second. The first one is easy, we know, that one is easy. The second is a consequence of triangle inequality. Yeah, that's the consequence of triangle inequality. Now, which you only see in geometry though. Right now here, we will just use that as a fact. We will not prove it, okay? And the third thing, something from what we learned in chapter 3, that sine theta, sine of any angle, okay, has the range from -1 to +1, right? We know that one. We know that one. But furthermore, if the theta is between 0 degree to 180 degrees, either in quadrant 1 or quadrant 2, then sine theta has to be positive or 0. And it will be only from 0 to 1. Okay? Okay. Now, yet, sine theta equals to a constant k has solutions in quadrant 1 and quadrant 2 if k is between 0 and 1. Not including 0, not including 1. Okay, let's say to remind ourselves, let's say for example, sine theta equals to 1/2. Then theta is 30 degrees, right? And that's in quadrant 1. And theta equals to 150 degrees, and that's in quadrant 2. Now, the thing is, the angle in quadrant 2, this angle here, has reference angle the same to what we have in quadrant 1. Okay? So once we get the angle in quadrant 1, the angle in quadrant 2 will be the supplement of that angle. Okay? Now we will combine these three facts here together in our work later on. Okay? So I basically summarize this section into these things, what I said here. Instead of explaining it the way our textbook explained it, I will just explain it that way. You have these three restrictions. Now, suppose, for example, I start working on problems. Suppose, for example, let's do number 8. Let's do number 8. Okay. The A is 43 degrees. The A is 31 feet. Side B is 37 feet. Find angle B. Okay, that's what we'll do first. Now after that, we will look for angle C and side C. Okay, but this is what we want to do first. That's what we want to do first. Okay, now let's see. Solution. Using law of sine, sine A over A equals to sine B over B. Sine 43 degrees over 31 equals to sine B over 37. If I multiply both sides by 37, then I will get 37 sine 43 degrees over 31 equals to sine B. Now I want you to use your calculator to compute what is sine B equal to when you compute that 37 times sine 43 over 31. Okay, do that. 0.81. 40. Yeah, 400. Okay, now then the angle B, the first possible angle will be the sine inverse of that number. I get 54.48841 degrees. And then the second possible angle is the supplement. because sine is positive in two quadrants, quadrant 1 and quadrant 2. Right, so this one I get 180 degrees minus 54.48841 degrees is 125.51159 degrees. Do you get the same thing?
How did you get B1 real quick?
Repeat again.
B1?
Sine inverse of, so that way you get the sine on the other side.
Yeah, sine inverse.
All right.
Yeah, sine inverse. I didn't, how to say, the one I used earlier, to get this, I used sine inverse of the more accurate number, 0.8139980427. Okay, that's what I get. Let me erase this for a while. So if you do that, you will get B1 equals to 54.48841 degrees, and B2 therefore 125.51159 degrees. Okay, now however, if what you use is sine inverse exactly this number 0.81400, if this is what you use, then you will get a bit off, 54.48860 degrees, slightly off, but don't worry about this. Okay, you can use either one and I'm fine. Okay, and then the inverse therefore is 125.51140 degrees. So you can use either one, the black one or the red one. Okay, the red one is more accurate though. The red one is more accurate. Okay, so you see that we have two angles here. We have two angles here. Now you need to check two things. The first thing is this: the first quadrant answer most of the time is true. Okay, I mean, why 43 degrees plus 54 is still less than 180, right? You see what I mean?
Yes.
Okay, the one you need to check, another one you need to check is what happened with the second angle. When you add B2 and angle A, is it more than 180 degrees? Just do it visually. It's still less than 180, huh?
Yes.
Right? Okay, so the first requirement is okay. The sum of any two angles, either B1 or B2, when we add to A, that's still less than 180. Now we need to check another one. So the first requirement, okay, A plus B1 has to be less than 180. A plus B2 should also be less than 180. Now both of them check. Okay, second thing you need to check is this. 43 degrees corresponds to 31 feet. So 37 feet should give you larger angle. Is that right? So either B1, which is 54 something, that's okay, or B2, which is 125 something, that's also okay.
You know.
Is it okay? You see what I mean?
Yeah. I was gonna say,
Yeah.
wouldn't you just look at which one's more realistic?
Yeah, you can just look at them. You don't need to write it down. You don't need to write it down this way. No need. But I write it down so that you don't lose track of what I'm checking. Okay? So with this, let me summarize. So there are two possible solutions. So the solutions are either B1, which is 54.48860 degrees, or B2, which is 125.51140 degrees. Now, the thing is, remember that when they say find all solutions, it actually refers to find angle D, right? There are two possible solutions, but notice that for B1, we have a corresponding C1. For B2, we have a corresponding C2. You see what I mean? So if you have using B1, then C1 will be the one correspond to that. If you use B2, angle B2, then you have angle C2 corresponding to that. And furthermore, you have side C1, you have side C2. Okay, if we solve that further, which I believe you can do it yourself, right? Okay, let me do C1. If I want to find C1, A plus B1 plus C1 equals to 180 degrees. DA is what, 43? And B1 is 54.48860 plus C1 equals to 180 degrees. So my C1 equals to 180 minus 43 minus, is it really 43? Yeah, that's really 43. Minus 54.48860. I get C2 is 82.5114 degrees. And therefore, from there, for me to find side C1, I will use sine A over A equals to sine C1 over side C1. Sine 43 degrees over 31 equals to sine 82.5114 degrees over C1, side C1. So side C1 equals to 31 sine 82.5114 degrees over sine 43 degrees. I get C1 equals to 45.06696 feet. Okay, now I would like you to do C2. Find your C2, please. And then once you get your C2, you get your side C2 with a very, very similar method. Now, after you're done with this C2, I would like you to go on with number 10. With number 10, which I believe you will get no solution. With number 10, you will get no solution. And then, how about number 18? Okay, this will be 5 minutes. Number 10 is 3 minutes. Number 18. Oh, right now it's 3. Let's say I will come back at 7:50. No break, no break. I'm not talking about break right now. 7:50. You should be done with at least up to part of number 18. and then we work together.
Professor, we can't hear you.
Sorry. Well, anyway, are we okay so far for my angle C2? We're good?
Yes.
Okay, now then, because angle C2 compared to B2 and angle A, angle C2 is the smallest angle, right? This is the smallest angle. Then side C2, consequently, should be the shortest one. Okay, so let's see. So sine A over A equals to sine C2 over side C2, sine 43 degrees over 31. Is it 31? Equals to sine 11.4886 degrees over C2. So C2 equals to 31 sine 11.4886 degrees over sine 43 degrees. So 31 sine of 11 something divided by sine 43 degrees. I get C2 equals to 9.05334. And this is in feet. Okay, as expected, C2 should be the shortest side of those three sides. Okay. If I summarize, then my angle A is 43 degrees. My side A is 31 feet. My side B is 37 feet. But then with that, I have two possible angle B's. The first one is 54. The first one is 54.48860 degrees. The second is 125.5140 degrees. Then for B1, it corresponds to angle C1. Angle C1 is 82. It is 82.5110 degrees. And that corresponds to side C1, which is 45.06696 feet. While the second branch angle C2 is 11.48860 degrees, and the corresponding side is 9.05334 feet. Okay, that's the summary. How about number 10? Number 10.
There's no solution because it's bigger than 1.
Yeah, because the sine of angle B is greater than 1. Okay, So 124.3 degrees correspond to side A, 27.3 centimeters, right? And then side B is 50.2 centimeters. We need to find side angle B. Okay, but visually you see that because side B is greater than side A, then angle A must be greater than side angle B, right? I mean, angle B should be greater than angle A. Is it right? So this is at least 124.3 degrees. But then you realize that the sum of these two already more than 180. You see that? Okay, but of course the way you argue should not be like this. You cannot argue like this. We know by looking at that there's no solution, but we need to show that in a systematic way. And the systematic way will be by showing the law of sine and show that the sine will be greater than 1 in this case. Okay, so sine A over side A equals to sine B over side B. Then sine 124.3 degrees over 27.3 is equal to sine B over 50.2. So let me just continue here. Sine B equals to 50.2 sine 124.3 degrees over 27.3, which is
1.519052.
1.5105, and then from there you say there is no such angle B, right? Because this is greater than 1. That's a contradiction, therefore. Okay, that's for number 10. Number 18. Number 18, angle A is 65 degrees. Side B is 7.6 yard. Side A is 7.1 yard. And what is angle B? So sine A over side A equals to sine B over side B. Sine 65 degrees over 7.1 equals to sine B over 7.6. And then so sine B will be 7.6 sine 65 degrees over 7.1. That is what? And 0.97013. So my B1 in the first quadrant will be 75.9.
96134.
And then my other angle B2 will be
No solution because it's greater than 180.
104.038. degrees. Is it right? It's okay though.
It's right. Yeah, it's right. I got the same thing.
Yeah, but you see, so we have two possible solutions here, B1, B2. So
So
the
if we
first one, hold on, what is B1 again? 75
B1,
some.
yeah, 75.96134 degrees.
So when I add this guy with this guy, it's less than 180,
Yeah.
right? Okay. Now how about the second B? How about B2? 104.03866 degrees. Which, when you add with this, it is still less than 180.
Okay.
Right? Okay. So see, either this pair, or this pair. This pair. Yeah, both of those pairs should not be more than 180. Okay. So I was expecting the B2 is actually get cancelled, but it turns out that's not the case.
But I have a question. Isn't the sum of the triangle, like the inside, it can't be greater than 180?
That's right.
But
Mhm.
if we get C, wouldn't it be greater? Oh, I can see what you're saying. Never
Yeah.
mind.
Later on we have C1, C2, but the way we get C2, that will be 169 something. Like 169 something, so there will be 10.96134 degrees here. And then C2 will be whatever, this is 130, no, that's 140 something. So that's 39 point, that would be 39.03866 degrees. Yeah, so both of them actually work. Yeah, both of them actually work. Okay, so this B2, the one that you suspect that we get cancelled, actually not being cancelled because the sum of B2 with A is still less than 180. Okay, anyway, we have done that part. So once we get from there, we get C1 and C2. They are two branches because both B1s and B2s are okay. Okay, and then from there we get side C1 and side C2. That's something we have done earlier. Okay, that's something we have done earlier. Do you want to work it out, or it's good enough?
We get the idea.
You get the idea, right? Okay. Now let me go on to 7.3. Suggested homework from here. Suggested homework from here. Number 1 to number... Actually, no, you don't need to start from number 1. You can just start from number 7. Start from number 7 to number 19. That's the suggested homework for 7.2. Now 7.3, Law of Cosine. Law of Cosines. What it says the following. Suppose we have a triangle. Let's say this is side A, angle B, angle C. Therefore, this is side B, this is side A, I'm sorry, that's side C. Side C, and this is side A. Now, according to law of cosine, it says the following. the opposite side, suppose we know two sides and included angle. Then we can use law of cosine to find the opposite side. Okay, so a squared equals to b squared plus c squared minus 2bc cosine a. Okay, now that's the law of cosine. So the length of the opposite side, let's use this color, is equal to the sum of the squares of the two sides, the other two sides, minus twice the product of those two sides by cosine A. Okay, now this angle A here is also called included angle. I think I mentioned that before. A is between sides B and C. So we say A is the included angle. As long as it is in between two sides. Okay, it's an included angle, not the included angle. Okay, now that's the first formula though. Okay, now if we play with, if you pay attention to the pattern, notice that this side A here, is the opposite of angle A. Okay, it's the opposite of angle A. So if I have B squared outside, if I want to find side B, then I will use A squared plus C squared minus 2AC cosine angle B. Okay, pay attention to how I permute the letter. Next, side C. If I have C squared alone on one side of law of cosine, then tell me what should I have on the other side?
A squared plus b squared minus 2 AB cosine C.
Cosine C. Good. Okay. Now, in the next couple minutes, I will give you the proof of this law of cosine. There are actually two different proofs, but I would like you to give at least one proof. The proof. Now, suppose I draw that again. So this is angle A, this is C, this is B, so this is side B, this is side C, and this is side A. Okay, now what is the length here? If I call this X, if I call that X, then X in this triangle, in this right triangle here, in this right triangle here, we get cosine A equals to X over B, is right? Okay, so X will be equal to b times cosine A. Is it okay? Now, then how about this guy here? The length here is c minus x. Is it right? Now, let me call this point D here. Okay, so BD must be c minus x, which is c minus b cosine A. Okay, so the length here, c minus x, is the same to c minus b cosine A. Now, how about the length here, which we usually call the height? CD. Notice that sine A equals to CD over B. So CD equals to B sine A. Is that right? I lost connection earlier, sorry. So continue. Triangle BCD, from what you see there, is a right triangle. So I can apply Pythagorean theorem where side A squared equals to CD squared plus BD squared. Okay, now CD squared is B sine A being squared, and BD squared is C minus B sine A cosine A squared. This gives me B squared sine squared A. That's for the first term. The second term, this guy here, I need to FOIL it. Okay, I need to FOIL that. So it will be C squared minus 2BC cosine A plus B squared cosine squared A. Right? Okay, so that's the expansion. Now the thing is, this guy plus that guy, if I add those two, so B squared, let me factor it, sine squared A plus cosine squared A. That's for the yellow part. plus c squared minus 2bc cosine A. That give us, this is equals to 1, right? So this is b squared plus c squared minus 2bc cosine A. That's what our A squared is. Okay, now that's the proof of law of cosine. Now after the break, we will do problems applying this formula here, law of cosine, into some problems in this 7.3. Okay, let's do actual break. Right now is 8:16. Let's come back at 8:25. Let's see on page, where's my, okay, number, what is good? Number 2. On page 340, we have side A is 120 inches, side B is 66 inches, and angle C is 120 degrees. We want to find side C. Now, you may have a question, under what situation we use law of cosine? We can mainly say that we use law of cosine when law of sine cannot be used. Okay, let me say it again. We use law of cosine if law of sine cannot be used. Okay? But you will see later on there are cases where there are times that we can use law of sine and law of cosine. If you have those choices of law of sine and law of cosine being used, then we prefer to use law of cosine. Okay? Well, anyway, we will do this first. We'll do this first. We'll find side C first. According to the formula, I need side C, right? Okay, so that will be a squared plus b squared minus 2ab cosine angle C.
Professor,
Yes?
why would you rather use law of cosine than law of sine?
Repeat again.
When given two options, why would you rather use law of cosine than sine?
I will explain it later on. Okay? It's a bit tricky to see, but with some experience then you will see why we prefer law of cosine. You can use either one, don't get me wrong. You can use either one, but then you will see that one of them is actually more effective. Okay? Now let's work this out. So c squared equals to 120 squared plus 66 squared minus 2ab cosine C. So 120 squared is 14400 plus 66 squared is 4356 minus 2 times 120 times 66 cosine 120. That's negative 7920. So c squared equals to 14400 plus 4356 plus 7920. That's 26676. So c, side c is the square root of that. I get 163.32789 inches. Is it okay? Now, suppose I will use these informations to find angle B. Suppose I want to find angle B.
You use laws of sine?
You can use law of sine. So to find, so let me write it here. To find angle B, we can use law of sine. Can you try doing that? We try. So I believe that sine B over B equals to sine C over side C. You do it, I do it too. I get 0.34996. So B is equal to sine inverse of that. That's 20.48466 degrees. That's B1. For B2, the supplement, that's 159.51534 degrees. So the reason I say that if law of sine and law of cosine usable, we prefer law of cosine because of the following. When you use law of sine here, notice that you have two possible B's, right? You have two possible B's, but notice that one of them doesn't work. Why? C is the largest angle. C is the longest side, right? So angle C should be the largest. Are you with me?
Can you repeat
Now,
that?
yeah, B instead, side B is the shortest, right? So angle B should be the smallest. So this will not be right. This has to cancel. Okay, maybe I write a note down there. We cancel B2 because side B is shorter than side C. So angle B must be less than angle C. Does it make sense?
Yes.
Okay, now I want to show you that actually in this formula that we have up here, if you know three sides, then you can use that to find angle. If you know three sides, you can use that to find the angle. Okay, now in this case, if I need angle B, then I need outside side B. That will be a squared, B squared equals to A squared plus C squared minus 2AC cosine Notice that we know three sides already at this point, right? Okay, so this is 66 squared equals to 120 squared plus c squared, but our c squared is 26676 from here. I get it from here. Okay. Minus 2 times 120 times 163.32789 cosine b. Okay, so this is 4356. This is 144 with 2 zeros. 26676 minus 39,100. You know what? 39,198.6936 cosine b. Now I will rearrange. Let me add these two first. I will add these two first. So we'll add these two first. So that is 40. From here is arithmetic or algebra. So that's 41,076 minus 39,198.6936 cosine b. And I will move this, the one with the angle, to the left, and the constant to the left, to the right. I will move this to the left, and I will move this to the right. Okay, so 39,198.6936 cosine b equals to 41,076 minus 4,356. 1076 minus 4356. That's 36,720. Then I will divide both sides by whatever the coefficient I have here. So cosine b equals to 36,720 over 39,198.6936. Now I try my best not to change that into decimal. Okay, just leave it like that. We do the b right away. B equals to cosine inverse. Now the reason is if you change that to decimal, you may have rounding error. Okay, we may have too many compounded rounding error. So leave it like that and then just use this number in your calculator. Okay, so cosine inverse of the answer divided by 3918.6936. So B is equal to 20.48466 degrees. Notice that we get the same answer with this. Okay. Now, the reason I told you that if you can use law of cosine and law of sine, if you are able to use both of them, okay, then law of cosine will give you only one answer. Why? Because cosine something is positive, right? Give you that angle has to be in quadrant 1 or quadrant 4, right? But once it is in quadrant 1, you cancel it. I mean, once it is in quadrant 4, you cancel it because angle cannot be more than 180. Now, suppose the cosine actually negative. Cosine of that angle is negative. Then that angle must be either in quadrant 2 or quadrant 3, right? But an angle in a triangle cannot be quadrant 3. So you cancel that. In other words, law of cosine gives you a unique one angle and you don't need to think about the other possible angle. Now, however, some teachers, including sometimes me, some teachers prefer to use law of sine anyway if the situation is pretty clear. Why? Law of sine is actually easier to apply. Okay, so I don't mind to get two angles because I know later on I can easily cancel one of them. I can easily cancel one of them by just observing, oh, you know what? This is the shortest side. So this angle here must be the smallest angle, and the smallest angle must be less than 90 degrees, strictly less than 90 degrees. Okay, in fact, both of these two angles here has to be less than 90 degrees. Now, the thing is, suppose earlier I asked you angle A right away, then you must have two angles, right? You must have two angles, one of them in quadrant 1, one of them in quadrant 2, and you will see you cancel the one in quadrant 2 because you already have something else in quadrant 2. Okay, so in other words, when I say that you can use law, in case that you can use law of sine or law of cosine, it's up to you which one you want to use. It's in that case up to you which one you want to use. If you kind of like know, you know what, this angle has to be in quadrant 1, it has to be the smallest angle, or if you kind of like be able to figure it out, then go for it. Okay, use law of sine. But there are times that you may have two possible angles, and you don't know, you cannot cancel any one of them. Okay, now in that case, if you cannot cancel any one of them, then the only way you find out if you can, which one, is really by using law of cosine, or you go further into the question. Okay, now let's see, for example, number 4. Let's see number 4. Number 4, side A is 13 yards. Side B is 14 yards. And side C is 15 yards. And the question is, find the largest angle. Which is the largest angle?
B.
Huh? What?
B.
Why? My bad. My C is 15.
Oh, C.
Yeah, angle C is the largest angle. Okay, now can you work it up? I'll give you maybe 5 minutes. No, 4 minutes should be good. Okay, try. Angle C. Find angle C. I need C square on the outside. Okay, so 15 squared equals to 13 squared plus 14 squared minus 2 times 13, 14 cosine C. 225 equals to 169 plus 196 minus, it's 26 times 14. What's that? 364 cosine C. What is this? 365 minus 364 cosine C. Am I correct so far?
Yeah.
364 cosine C equals to 365 minus 2.5. So 364 cosine C equals to 140. So cosine C is 140 over 364. C equals to cosine inverse of that ugly number. Cosine inverse of 140 over 364. That is 67.3801 degrees. Do you get the same thing? Because it's, I see 135, so I make it 14. Do you get the same answer?
1 second. Yeah.
Okay. Now then, because that C is the largest angle, then for angle A and angle B, it's definitely has to be less than 67 degrees, right? It must be less
Yeah.
than 67 degrees. And because of that, if you dare enough using law of sine, I think it's okay. Let me use law of sine. Suppose I want to find angle B. Okay, then sine B over B over equals to sine C over C. And then I will get sine B. I go fast forward a bit. Sine B is equals to 14 sine 67.3801. Let me be a bit more accurate. 135 degrees over 15. So that's 14 sine that angle divided by 15. I get 0.86154. So B equals to the sine inverse of that. I get 59.48976 degrees. Now you need to give me two angles and cancel the other one. Okay, so 180, so that will be 120.51024 degrees, because the solution for sine B equals to that, there are two solutions, but then you cancel this one, you cancel that one, and then you say, and give the reason, because either you say C is the largest angle, or second, you say that B2 plus C is greater than 180 degrees. Okay, either one of the solutions, either one of the answers, either one of the reasons. Okay. Now I'm basically done with this section. Some application. The first application is the following. The first application is this. You know stop sign?
A stop sign? Like
The stop sign. It's a regular 8-sided. We call that regular octagon, which means it has 8 sides. Each of them are congruent to each other. Okay, I try to mimic stop sign.
Beautiful.
I try. I did have a student at Santa Monica say they don't know what a stop sign looks like, even though they drive.
That's scary.
Yeah. So let's say, and when we say regular, it means all sides are congruent. Okay, and the interior angle, the angles here are all congruent, are all the same. Okay, that's what we meant by regular. So for example, a square is regular because a square has congruent sides and congruent angles. Okay, now suppose I have an octagon whose radius is, let's say, 10 centimeters. Okay, so let's say a regular octagon with radius 10 centimeters. And the question is, find the perimeter. Now we have 8 congruent sides. So once I know the length of one side, I multiply that by 8, I will get the perimeter, right? Now the thing is, how do I find the length of one side? The radius is 10 centimeters. Okay, how about the central angle? What is the angle here? Call that theta. Now angle theta will be 360 degrees divided by 8. It's 8 sides, so there must be 8 triangles. Can you see what I'm doing?
Yeah.
Okay, now then in that each triangle, notice that I think 360 divided by 8 is 45 degrees. Now this 45 degrees is the included angle. Okay, so one side S, the side S, okay, S squared equals to 10 squared plus 10 squared minus 2 times 10 times 10 cosine 45 degrees. S squared equals to 100 plus 100 minus 200 cosine 45 degrees. S squared equals to 200 minus 100. This is 200 times 1/2 radical 2, right? So this is 200 minus 100 radical 2. Let's use my calculator. 200 minus 100 radical 2, that's 58.57864. So as when I do the square root, I get 7.65367 centimeter. So the perimeter is that number multiplied by 8. I get 61.2293 centimeter. I usually ask this type of question. I may use hexagon, I may use decagon. Decagon means it's 10 sides. Okay, that's one application. There's another application from our textbook. Let me use question number 20. Question number 20, geometry. The diagonals of a parallelogram are 14 meters and 16 meters and intersect at an angle of 60 degrees. Now, what is a parallelogram? Parallelogram looks like this. This is parallelograms. Parallelograms means you have opposite sides are parallel. Opposite sides are parallel. Now, from geometry, you will see that the diagonals of a parallelogram actually bisect each other. So when I say bisect each other means this guy is congruent to this guy here congruent to this guy. Okay, now they say that the diagonals are intersecting at 60 degrees. Okay, so where's the 60 degrees, Thomas? Well, the angles must be this one or that one, right? But the 60 degrees must be the one facing the shorter side. This is the 60 degrees. Okay, now then you have 14 and 16. Which is 14? If I say this is A, B, C, D, and we have two diagonals, length 16 and 14, which diagonal is the 16?
The small with the one with the smaller angle. The one adjacent to the smallest angle. So A and D.
No. It's either AC or BD, which is the diagonal that correspond to 16 meters. Now you will see that you have the two diagonals, right? Diagonal 1 is 14 meters. The other diagonal, the larger one, is 16 meters. Now the 16 meters will always be the one, the longer one, the longer in this case, this guy here will be this one. The longer one will be the one opposite from more than 90 degrees. Okay, now the 14 corresponds to the shorter one. Okay, now then, if I look at the triangle, if AC is 16, then what is AE?
8.
8. This is 8 meters. And how about this one here?
7.
7 meters. Okay, now the question is, find the length of the longer side. Oops, okay, I need the longer side. The longer side of this parallelogram is either this one or this one. Okay, let's use this triangle. Okay, let's use this triangle. So, what is this here?
8.
This is 8 centimeters. What's the angle here?
120.
120. It must be supplementary to that 60, right? So then,
Is
the
8
longest
meters or
side,
meters or centimeters?
oh, meters. That's right. Thank you. That's meter. Okay, so side DC squared equals to 7 squared plus 8 squared minus 2 times 7 times 8 or sine 120 degrees. Okay, and then from there you compute, you will be able to finish it. Now your suggested homework from here, suggested homework will be from this 7.3 will be from number 1 to number 19 should be good. Number 1 to number 19. That's what we need. Now, and on Wednesday, I will do 7.4. On Wednesday, I will do 7.4 and 8.1. Maybe 8.1 with 8.2. 8.2, I'm sorry. Let me write it down. I'm sorry. So on this Wednesday, what I will do is I'll do 7.4 and 8.2. Okay. Now the thing is, I would like you to read. Just read it. If you don't get it, you are totally fine. Read section 8.1. Okay. Read section 8.1. Now, on Wednesday, I will do 7.4. That will take approximately 1 hour, maybe less. And then I will go over 8.1 super fast. And then I will do part of 8.2. Maybe, yeah, 8.2. I'm sorry. I will do 8.2. Okay. Now, that's on Wednesday, and then on Monday next week, Monday, I will do 8.3, 8.4. And then Wednesday next week, the week after that, I'll do 8.5 and part of 8.6. I don't think I will be able to finish 8.6. Yeah, but then the Monday after that, so what is the date today? Today is the 11th. So, I'm sorry. So this Wednesday is 13th. Okay. So the Wednesday after that is May the 20th. The Monday after that is Memorial Day. We don't have class. And I believe your test 4 is on the 27th. This is your test 4. And then on June the 1st, we still have class on June the 1st. This is last day of class, so we will do review. Okay. And then on the Wednesday, no class. You may have finals with your other class though. Your final week starts from Tuesday, the 6th, the 2nd, up to the 9th. Okay, now our final is on the 9th. So you have one extra weekend actually to study for. No, I should say you have 2 weekends to study for your final. Actually. Okay, so that's the plan so far, and I will just stop it here. Let me know if you have a question.
Is the final the same amount